Hi, today let's talk about Caley Hamilton Theorem. So why I created these kinds of videos always is because I feel like when I want to learn this kind of topic, when I search on YouTube, but I don't have a video that is comprehensive enough for me to learn everything in one video. So I plan to create this kind of video to make contribution for students to prepare well in the exam using shorter time. Okay, let's go ahead. So this theorem is you're gonna learn after you have learned the eigenvector and eigenvalues. This is a derivative of eigenvectors and eigenvalues. So after you have to have the basic knowledge about eigenvectors and values, only we can learn on this topic. Okay. So this method is another method to find the inverse matrix. If you still remember what inverse matrix is. Matrix is a series of numbers, then we're going to find the inverse of it. Okay. So let's go ahead, we're going to try to show this method theorem. Okay. So this theorem says that for every characteristic itself, the matrix has its own characteristic polynomial. So what it means is from eigenvector, we have the characteristic equation, which is A minus lambda I, 0. Yeah, this is determinant of A matrix minus lambda. Lambda is an eigenvalue times the I matrix. Okay, so here, let's say we have a function. We say this function is as a function of lambda. Okay. So for example, I just say a number. Let's say after I calculated this, I will get some number is equal to lambda squared. Sorry, or so lambda squared minus 3 lambda minus 4. Okay, in terms of this is as a function of lambda. So Caley Hamilton theorem itself says that, just very simple, say this is equal to f of A. Means the matrix itself has its own characteristic equation. Means we just substitute A equal to lambda. So means we just change all this lambda into A. And that's it. And this is what the Caley Hamilton theorem says. And how can we find the inverse matrix? Okay, let's say we already substitute this as A, okay, as a function of A, right? Okay, and this is equal to 0. In order to make it, I'm gonna times the whole equation with inverse matrix. Then here I'm gonna put in front here, in front here, in front here. So I'll get if inverse matrix times A squared, then I will get A. And if -3 inverse matrix times A itself, and I get identity matrix, which is I, and -4 times inverse matrix is just like this, equals 0. Then I can rearrange it. Therefore, my inverse matrix equal to 1/4 of A minus 3I. So straight away, since I already given the A matrix, and I can straight away find the inverse matrix very simple using this relationship. So Caley Hamilton theorem is a way for us to find inverse matrix, another method. Okay, so we can try out some example. So in the example, I talk about 2 times 2 matrix and 3 by 3 matrix. Let's go for a simple one first for you to understand. Okay. Let's say I have a matrix which is A is equal to 1, 3, 2, 2. Okay. So we start from the characteristic equation. Okay, this is the characteristic equation. Equal to 0. So my A is this one. So modulus 1 minus lambda 2, 3, 2 minus lambda. Okay, if you don't understand why it's get this, because A is 1, 3, 2, 2, I can minus lambda times identity, which is identity matrix, which is diagonal has 1, 1, 0, 0. Then 1 minus lambda, I got this. 2 minus 0, so I got me this, and so forth. Okay. And I have strict line means the determinant equals 0. Okay, so the determinant is very simple. We just cross this one is 1 minus lambda times 2 minus lambda minus the second cross, 2 times 3, which is 6 here. Then I'm going to expand my bracket. 1 times 2, I got 2 minus lambda 2 lambda, 1 times negative lambda plus lambda squared minus 6. Then I can summarize that. Therefore, I got lambda squared minus 3 lambda minus 4. So I got this. This is my characteristic equation. Okay, I'm going to erase the rest. And this is equal to 0. Okay. Then we apply the Caley Hamilton Theorem. Okay. We say that we can substitute the function of lambda as a function of A matrix itself. So substitute A squared 3A minus 4 equals 0 like this. Then we will arrange it. First we times inverse matrix both sides. Then we will arrange it, which is same like just now what we found. 4 A minus 3I. And we're going to make it 104. So A is this, 1 minus 3 is, all right, I just write first, 3, 2 minus 3. So I got 1 minus 3, negative 2, 4, negative 2, 2, 3, negative 1. Okay. Then I got this. This is my inverse matrix. And then we kind of double verify whether is this inverse matrix is valid or not. Then we're going to use the traditional way to find an inverse matrix for 2 by 2. For traditional matrix, traditional way is like AB minus BC. Then we change it, become this is A, and this is D, become DA. So minus B minus C, like this. So for inverse matrix, here I straight away equal to 1 over 1, 2 is 2 minus 2, 6 is 4, 6, so 2 minus 6 is negative 4. Okay. And then I'm going to reverse these two number, 1 and 2 become 2, 1, and then negative 2, negative 3. Okay. Then I gotta times the negative sign inside. Become negative 2, 2, 3, negative 1. So it's exactly same as this one. So it is proven that Caley Hamilton Theorem is another way to find the matrix of inverse. Okay. Let's try for 3 by 3 right now. Okay, 3 by 3 matrix. So let's say given a matrix which is A. Okay, as the first step, we also need to find the characteristic equation, which is determinant of lambda I 0. So which is determinant for 1 minus lambda and 3, 2 minus lambda, 4, 1, 2, 1 minus lambda, 3, 7. So as you can see here, it might be a nightmare to use because you're gonna have 3 terms like lambda cube. So don't worry, I have a shortcut for you to calculate when this 3 by 3 matrix, when we have to calculate the characteristic equation in terms of lambda itself. Okay, so here we write down the formula for this equation. So here is the formula for finding the characteristic. So I'm gonna explain. So what is mean by the words here? Diagonal element. So diagonal element is, I'm gonna put the summation of all of them. Okay. So diagonal element, which is here the diagonal. All right. So the summation of diagonal element is 1 plus 2 plus 1, which is 4. So I got lambda cube minus 4 lambda squared. Okay. And this is for the lambda element. And here the summation of diagonal's cofactor. Okay, what is cofactor? So cofactor is, let's say, this is a diagonal, the first element of diagonal. The cofactor is, I'm going to cover the column and the row. Then I'm going to find the determinant of the remaining here. So which is here, this thing. I have to find the determinant of 2, 2, 3, 1. Okay. So 2 minus 6, so it's negative 4. Okay. Plus negative 4. And not yet done, because we're going to find the summation of all of them. Then we have to do this is the second element for diagonal, it's like this one. Okay. Then I cover the row and a column, which is left 1, 1, 1, 7. Then again, I can count the determinant of 1, 1, 1, 7. So 1 minus 7 is negative 6. Okay. Again, continue with the third diagonal element, which is this one. Then count the row and the column, find the determinant of rest. Will be 1, 4, 3, 2. Then 2 minus 12, so it's negative 10. Okay, so here negative 4 minus negative 6, negative 10 is negative 20. So I straight away become negative 20 lambda. Okay, cool. And we need to find the determinant of A, all right? So if you forget how to find the determinant A, is this element times, just now like this one, minus, okay, then right, we do together, let's say find the determinant A, minus determinant of A is, have a big bracket first. Okay. So 1 times, I'm gonna pick up all this element. Remember the first element here is negative, positive, negative, positive. Okay. So 1 times I'm gonna cover first element here, which is 2, 2, 3, 1, which I just found just now is negative 4. So times 1 times negative 4. Okay. And continue with second element, which is 3. So going to be negative 3 modulus determinant, or find the cofactor, 3's cofactor, which is 4, 3, 1, 1. Okay. So 4 minus 3 is 1, so negative 3. And the next one is 7. I cover the row and the column. Then I got plus 7, 4, 1, 2, 2. So 8 minus 2 is 6, so 7 times 6 is 42. Okay. So -4, -3 is -7. So plus 42 is positive 35 times negative. So overall is negative 35. And this is a characteristic equation equal to 0. Then I found my characteristic equations. So you can have a note down for this shortcut. It makes your life much more easier. Okay. All right. So once we get this characteristic equation, we can apply the Caley Hamilton Theorem, which is simply substitute the lambda into a cubed minus 4a squared minus 20a minus 35 equals 0. Then I can rearrange it nicely because I want to find the inverse matrix of A. Okay. So we continue for finding the inverse matrix, the whole thing at the time by inverse matrix. So A cubed become A squared minus 4a squared become a minus 20, a become I minus 35 inverse matrix 0. Then I'm going to rearrange it nicely, equal to 1 over 35 a squared minus 4a minus 20i. Alright, this is my inverse matrix. So first, because I have to find this one first, I'm going to do it separately, a squared. So a squared means a times a itself. So I have my a is given times a 731. Okay. So for multiplication is okay, the first element here, first element only is the row times this column, first row, first column. And the second element here is the first row times the second column. And the third element is first row, third column, and so forth. Okay. Then we can go ahead to make it first row times first column. 1 times 1 plus 3 plus 7 is 11. So I should get the first element, which is 11. Which is 11 here. Okay, cool. And wait a minute. Sorry, I copied this wrongly. It should be 4. So, my bad. So again, first row, first column, 1 plus 12 plus 7. So here is 20. Right, first element is 20. Then we can go ahead to second element. Okay, so if you already know this, so you can skip this part. 3 plus 6 plus 14. Then I should get 23. Okay, and first row, second column, 7 plus 9 plus 7. 14 plus 9, also 23. All right. And then we can continue find for second row, first for this element. 4 plus 8 plus 3, which is 12 plus 3 is 15. So forth. Then you can continue the step and you can find in the end a times a, we got 22, 37, 10, 9, and 14. Okay. So we can go ahead to substitute here because we're going to do the calculation. Okay, so a squared minus 4a. So a squared is 20, 15, 10, 3. Minus 4a, which is 141. Okay. So 20 minus 4 is 16. 23 minus 12, because 3 times 4 is 12, is 11. So 23 minus 28 is -5, and so forth. And you might get 15 minus 6 is -1. 22 minus 8 is 14. 27 minus 12 is 25. 10 minus 4 is 6. 9 minus 8 is 1. 14 minus 4 is 10. So I got my a squared minus 4a. And I got a minus 20 some 20i. Okay, yeah, this might take a while. Okay, I have to copy again. And then minus 20i is 1, 1, 1. The rest are 0 because the identity matrix like this. So it's going to be 16 minus 20, which I get -4. The rest remain the same except the diagonal element. 14 minus 20 is -6. 10 minus 20 is -10. Okay. All right. And this represents a squared minus 4a minus 20. Therefore, inverse matrix is just 1 over 35. And this is the inverse matrix. Right. Okay. So, and this is how we're going to make this work for the inverse matrix for a 3 by 3 matrix. Okay. So, you can try yourself out. Let me give you another example. You can try it yourself. So you can try this out. A equal to this matrix, and you'll find the characteristic equal to this one. And in the end, the inverse matrix you find is 141. Alright, so that's all for this video. Remember to like and subscribe to my channel. Thank you.